All right. In this video, we'll talk about how to draw a general solution to a quadratic equation, and we will use this formula to solve a few quadratic equations. As we know, the general form of a quadratic equation is given by ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Now, we will get a formula to solve this kind of quadratic equation. Solving this equation means we need to make this x the subject of the formula. How do we isolate this x? So that it's just it stands alone on the left hand side of the equation, and on the right hand side we have expression in terms of a, b, and c. To do this one, before actually we continue this, at the end of this procedure we will obtain this expression. Let's see here, this x is equal to negative b plus minus square root of b squared minus 4ac over 2a. So if you're given a quadratic equation in the form ax squared plus bx plus c equals 0, actually, if you're given any equation that leads to quadratic equation, first we have to write it in standard form, and after that we have to determine the values of a, b, and c, and substitute the values into the quadratic formula, into this, and simplify this. Okay. So now here our quadratic equation is ax squared plus bx plus c is equal to 0. So in our definition, we know that a is not equal to 0. Actually here, I'll try to express this quadratic equation in the form x plus p squared is equal to q. To do this one, first I need to separate perfect square from this expression. First, I will start by dividing by a. If you divide both sides by a, since it's a non-zero number, so here we have x squared plus, and here we have b over a, and here we have x plus c over a is equal to 0. Now in the formula, we know that we have 2. How can I get 2 here? By just doing simple manipulation, I just multiply by 2 and divide by 2. Here we have b over 2a times x, right? And here I have x squared, here we have x, we have 2 in the formula, but I need the square of this number. So I just add and subtract this one. Before this, let me just take this c over a to the right hand side. So that's equals minus c over a. So now if I add b over 2a squared to both sides, we get this expression x squared plus 2 times b over 2a times x plus b over 2a squared. And how about here? We have b over 2a squared, right? And so we have minus c over a, minus c over a. On the left hand side, we have perfect square, a squared plus 2 times a times b plus b squared. So we can just write it as x plus b over 2a squared. And on the right hand side, if you just simplify this, b squared, right? And in the denominator, we have 4a squared. To get 4a squared here, I should multiply by 4a. So here we have 4ac over 4a squared. Now here on the left hand side, we have something squared. On the right hand side, we have expression. How can I continue? Before we continue this, let me just denote this expression by delta. That is called discriminant of the quadratic equation. So our delta is equal to b squared minus 4ac. As you see here, actually we need to consider 3 cases. If delta is positive, that is greater than 0, at the time here we will have 2 different solutions, 2 distinct real solutions. If delta is equal to 0, it has 2 solutions, but they are equal to each other. If delta is less than 0, Here we have negative number over positive number, right? On the left-hand side, we have non-negative number. So non-negative number is never equal to negative number. At that time, it doesn't have solution. So we are going to consider three different cases here. Delta is equal to, let's say, greater than 0. Delta equals 0. And delta less than 0. Okay. So here, we have no solution. And when delta is equal to 0, on the left-hand side we have 0. The solution will be only 1. X will be plus negative b over 2a. So here x1 equals x2. And here, when delta is greater than 0, we have two solutions, and they are not equal to each other. They are distinct. Okay. So now I have this expression here, x plus b over 2a squared is equal to what we have here, delta over 4a squared, right? What number squared equals 0? So here we have x plus b over 2a is equal to, I assume that here delta is positive, at least not negative. Because if it is negative, we just stop here. So, and that's why this equation has no real solutions. Equals, here we have plus minus square root of delta over, here we have 2a. Right. Now, if I just say this to the right-hand side, 2a, they have common denominators already. So we will get this. Here we have, draw a single fractional line. Here we have 2a minus b, because changing sign, plus minus square root of delta. All right. So to solve this quadratic equation by formula, first we need to bring the given quadratic equation into the standard form, and after that determine the values of a, b, and c, and substitute here. We will get the solutions. Okay. So here, what is the first root of this equation? That's equal to minus b plus square root of delta and over 2a. And the second root of this equation, if delta is greater, it is minus b minus square root of delta over 2a. So immediately, let's use this in an example. In example 7, solve 4x squared plus 3x minus 2 equals 0, giving an answer correct to 3 significant figures. So here a is equal to 4, b is equal to 3, right? And this is a, and this is b, and this negative 2 is c. So first we need to evaluate delta. Delta is equal to b squared minus 4ac, which is equal to, what is b? It is 3. 3 squared is, okay, let me just write first 3 squared minus 4 times a equals 4 times c equals negative 2. And which is equal to 4 times 4, 16, 32, minus plus 9 is equal to 41. So here our first root to this equation will be, what is it? Minus b, right? It is minus b plus square root of delta over 2a, which is equal to minus b. What is b? It is 3. So here we have negative 3 plus square root of 41 over, and 2 times a, that is 8. Right? And it says that correct 3 significant figures. Correct 3 significant figures. Here we have minus 3 plus square root of 41 over 8. That's equal to 0.4253, blah, blah. So correct 3 significant figures starting from the first non-zero number. We should just write 3 digits, right? Dot. It is 425. 4, 2, 5. And after it is 3, so it is 3 significant figures. Okay, how about x2? x2 is exactly the same, but only the sign is different, right? It is minus square root of delta over 2a, which is equal to minus 3 minus square root of 41 over 8. So which is equal to, when it is minus, that's equal to minus 1.1753. So if you just round off this, it is 8. Correct, 3 significant figure. Starting from the first non-zero number, it is 1 and just count 3, 1, 2, 3. These figures are significant, important for us. And the rest we just round off. Okay. Another example, solve the equations given below. That means that using the formula. Question A, so it's already in standard form. We don't have to do anything. Just immediately we can use the formula to solve this equation. So here we need to find delta equals b squared minus 4ac. And what is b? It is negative 42 squared minus 4 times a is 9 times, and c is 49, which is equal to, so here we have 42 squared minus 4 times 9 times 49, which is equal to 0. Actually, 0 means that is a perfect square, right? Anyway, I can just write it as 3x squared is 2 times 3 times 7, and times that's equal to 7 squared. Anyway, using this formula, we know that we get two answers, but they will be equal to each other. So here we have x1 and x2 equals minus b, and plus minus delta. Delta is already 0. Here we have nothing, over 2a, which is equal to minus b is 42 over 2 times a, it is 18. And if you simplify this by, actually we can divide by 6, 42 and 18, they are divisible by 6. Here we have 7 by 6, here we have 3. Okay. How about question B? Question B, here we have delta is equal to minus 10 squared minus 4 times a, it is 5, times c, it is 13, which is equal to 100 minus 20 times 13, that's equal to minus 160, right? Since this one is less than 0, you can stop here. Here, dots, 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 also here, dot, dot, dots. This equation has no real roots. Okay. All right. In our next video, I will continue with equations reducible to a quadratic equation.